Great. All right. Hello, everybody who is attending. Good afternoon, and I'd like to thank you on behalf of Pearl Engineering. We'll start in a few minutes here just to give everybody a chance to get on, probably about 12:01, so another minute or two. If you have any questions, comments, or concerns during the webinar, please direct them to the Q&A on the right-hand side of your screen, and we can answer any questions there. If you don't have any questions at that point, we can answer those at the end or in an email privately after the webinar. So we're just going to give it a few minutes here, and we'll get ready to go. So thank you for attending, and we'll start in 2 minutes.
All right, everybody, we're going to give it about 1 more minute and then we should be ready to go.
Okay. Hello, everybody. Thank you for attending our boiler webinar. We're going to get started here. If you missed it, as you can see on the right, I have chimed in. There's a live event Q&A section off to the right-hand side of your screen. Feel free to type in any questions you have there. We'll have a spot in the middle of the presentation where we can discuss those, and then also at the end of the presentation. So the format of this, it's going to be about 20 minutes. Open up to any questions halfway through and at the end, like I said. And today our speaker is Mike Anderson, one of our professional engineers, our mechanical professional engineer with 16 years of field experience. And today we're going to be talking about everything power boilers. He's worked with coal, oil, biomass, and natural gas boilers and everything in between. We also have our scanning webinar that'll be happening at the beginning of August, and we'll also have our second boiler webinar in October or September. So with that being said, I'm going to send it over to Mr. Anderson, and you're live now, Mike. So whenever you're ready.
Yeah, thanks everybody for joining us here. Mike Anderson. I've been with Pearl Engineering for about 6 months. Before that, I was with a paper company at the power plant and steam plant there. I worked for an electric utility and for a boiler OEM previously. So.
All right, Mike, I'm going to send it over to the PowerPoint right now. So away you go.
All right, today we're going to discuss routine boiler maintenance and optimization. In most facilities, the boiler is sort of the lifeblood. It's what drives the plant, whether it is a paper mill, processing plant, or an electric utility or steam plant for heating. Routine maintenance and optimization is key to ensuring that your business stays online and reliable and profitable. The boiler typically doesn't get much attention until it's down and you're in a bad place. Keeping up with your routine inspections helps you prevent tube leaks, and it helps you maintain your environmental compliance. With the new regulations that the EPA's handed down, like the IBMAC and the UMATs, it's important to do internal inspections in your furnace to look at your burners and other equipment. It's important to perform long-term evaluations on your boilers. Across the industry right now, about 50% of operating boilers are at least 40 years old. There are techniques to look at your superheat outlet headers and your superheat tubes and determine how much life you have left in them before you're ready to plan a capital project for replacement, or on the other side, if it makes sense to look towards retirement. There are optimizational techniques that can be done for your operations to make sure that your boiler is operating as efficiently as it can and that your emissions are where they should be. Another key here is that you keep up your maintenance. I know everyone is going through budget cuts currently on their O&M side, especially. This particular webinar is supposed to have taken place last week, but thanks for everyone that rescheduled for today. I got called to a customer site and they were offline. They were forced offline, and it was because of deferred maintenance on their boiler. It was just routine cleaning maintenance, and they had to plug up and were taken offline. And it was electric generating unit, and it was probably the hottest week we've had in a while, so there was some lost revenue there. Planning routine outage inspections. I don't know how often your facility performs internal inspections, but every year it does make sense to get inside and take a look around. It's difficult to see everything that's going on inside your boiler just from viewports and from your DCS and PLC information. By getting inside, you can help prevent tube leaks, which are going to avoid your forced outages, obviously improve your reliability, and your safety of your facility will improve. Anytime that you come down for a forced outage, there's a huge rush to try to get the repair done as fast as you can and get it started up. If you can schedule your maintenance so that it takes place during your scheduled outages, your facility can see a safety improvement. You're also going to reduce your cost of scrambling, a crew of Boilermakers on site. Your fuel for startup is a waste, and your facility is going to have lost revenue while your main boiler's down. One statistic I found was from Power Magazine. It was a 10 years ago statistic, so some of those older boilers have been retired now, but boilers were averaging 7 tube leaks per year from a Power Magazine survey. So it kind of shows the importance of getting inside, doing a thorough inspection, and getting ahead of the tube leaks. Sometimes you can discover operational issues you didn't know you had, or you can find the root cause of your issues. Say you got pluggage in a duct, your ID fan was working harder than it should. You're not going to know that unless you get inside and take a look. Primary area of focus during inspections is usually in the furnace. It gives you a chance to inspect your burners. Burner parts do wear out over time, or can fall off, or your louvers can become loose. This is going to affect your flame stabilization, and it's going to make your NOx and CO control out of whack. Gives you a chance to clean your scanner eyes and inspect your pitos, your pilots, and your igniters, which is important for your startup. Your startup time can be decreased coming out of that outage if you take the extra effort and make sure that your igniters and burners are ready to light back off. They don't get used that often, usually just coming out of an outage. And now, like I said, it's a UMATS and IB MAC requirement that at least every few years, depending on if you're UMATS or IB MAC and your size, the burners do get inspected. One other short thing to touch on with furnace inspections. It is important to take the extra time and plan your furnace rigging. If you're installing a scaffold or if you have swing stages installed, these should be thoroughly evaluated by each person before you enter. You should have a good plan for setting this up. However, they're set up by professionals. Professional scaffold builders typically install them, but it should be inspected. I've found several times where the lifelines aren't set up the way that they should be. They aren't tied to something properly. So take your time, please, when you're looking at your furnace rigging. Emergency descent options are preferable, as if there is a problem while you're on the swing stage, you have an easy and fast way to get someone down, whether it's an equipment failure or a medical problem. Primary thing to look at during a furnace inspection are your water walls, besides your burners. You want to look at, if you have IK wall blowers, you need to look for erosion. If you have new hydrojets or water cannons, and especially if they're new to your facility, you should look at any sort of cracking or embrittlement. Your burner openings are exposed to more erosion because of the eddies and the strange combustion aspects, which can lead to some corrosion around the tube ends. During furnace inspections, you should do furnace mapping every 5 years or so. That's kind of a rule of thumb. It's valuable information to map out your thicknesses around your furnace. However, if you hire a lot of NDE companies, they will draw a line and they will measure every other tube 10 feet up, every 10 feet, or whatever you prescribe to them. If it's important that you take a good visual around your furnace, and that you have a flashlight, and that you're looking for low spots, and that you're not just taking the reading every X number of inches or feet. You can easily miss something. If you're not doing a thorough enough inspection, you could miss something like what was found in this boiler. This shows a flame side corrosion. It's a newer phenomenon now that overfire airports are used primarily to control NOx emissions, and you can see the pitting on the tubes. That could not really be seen. It was so localized in certain areas that if you were just randomly measuring at the peak of the tube, you would not see that around the top side of the tube you had the severe corrosion that was nearly a third of the tube wall thickness loss. Drones are becoming more popular for inspections, and they're good in certain applications. However, if you do employ drones, keep in mind that it's visual only, and it's only from one frame of reference. If you've used borescopes for inspections before, your frame of reference is sort of thrown off, and small imperfections can look very large with a borescope. It's similar to that with drones. You can't get good thickness readings. You can't really get a shadow to see if you have tube wear. Your burner fronts, you can see one view. A lot of the times especially with coal burners, you're going to have erosion that's deep inside the burner itself, inside the nozzle, or on a T-fired CE, it's going to be inside the buckets typically. You're not going to see that from straight on. You have to have someone in the field feeling and looking. And I've gone in after a drone inspection and found much more damage than was anticipated. Backpass inspection, or the convection pass. Flash erosion is not as large a problem as it used to be, typically because there's less usage of eastern bituminous coal now. Subfloor erosion is one of the most important areas to look for. Unless you have a gas-fired boiler, you are going to have subfloor erosion. It's important to be patient while you're performing this inspection work. Use a flashlight and look for shadows. Take ultrasonic thickness readings as often as you can. When you're looking for subfloor erosion, a lot of times you'll find it's not necessarily straight above or below that subfloor, but anywhere that you have hanger tubes and that intersection between the bank above and below and the hanger tube. Subfloor steam typically will ricochet off the hanger tube and start to cut right at that interface. Everybody's got a different interface, every boiler manufacturer, whether it's a scallop or some sort of handcuffs, and they're all prone to accelerate that subfloor erosion. Sometimes you'll find something you weren't anticipating, such as alkali chloride corrosion. One boiler I was inspecting a few years ago, there was excessive ash buildup on the tubes in the secondary superheater and primary superheater. We thought there's no problem with erosion because there's so much buildup straight above the subfloor. Maybe the subfloors aren't as effective as they should be, but the lanes were clear. It was just build up on the tubes. One thing we didn't notice until it was too late was that under that deposit, underneath that ash deposit, there was corrosion taking place, and you can see the severe pitting on that tube sample that ended up coming out as a leak. That facility was forced to replace their entire secondary superheater assembly with an upgraded metallurgy, and we changed the controls slightly so that it would force the temperature range on that superheater down a little bit. There is like an 850 degree happy point for alkali chloride corrosion, so we tried to use the temperating sprays to help protect the tube life. While you're down for your inspection outage, it's important to check not just the boiler proper, but all the auxiliary equipment. Go inside your deaerators, inside your storage tanks to inspect your welds to make sure that they're holding up. Should be done every 5 years. And look at your nozzles. That can cause internal water side damage if your nozzles aren't operating properly inside your DA. You can look at your steam coils and your air heaters. Any sort of pluggage is going to cause your fans to be overworked. Backhouse and precipitators should be inspected periodically to make sure they're in good standing, and check your ductwork and your flues. You could have some sort of resonance that you didn't even know existed. You could have damaged internal supports. It's a good idea to inspect your fans and stay on top of your pulverizer maintenance if you do have a pulverized coal unit. So there was a tube leak and you got forced offline. It's important to be patient and be thorough with your inspection. The initial reaction, every facility, is to try to get in, make the repairs, and get out as fast as you can. It's critical that you do a good root cause analysis for every tube leak. This will help you avoid future outages. If you had a tube leak for some reason, there are other tubes in that same bank that are affected by the same failure mechanism, most likely. There's also collateral damage. Once you have a tube failure, that steam likely cut another tube near it. If that tube is not also leaking, that tube is at a risk due to the steam erosion. During a forced outage, you also get a chance to do a little bit of extra inspection while the repair is taking place. You can help to plan for your next upcoming outage, what you need to do. And taking this time and having a plan, having the equipment you need to make your planned repairs instead of being reactive will save you time and money. If you can, collect a tube sample from the failure. If you're not sure why it happened, you can have metallographs done on the tube. You can have experts look at the failure and try to figure out why it happened. Let's look
All
at
right. We are at our first question break. Mike, we did have a question from Ciro.
Yes.
And I'm going to publish that right now so everybody else can see it. The question says, has Pearl Engineering developed any chart or guideline to recommend or evaluate gas burners efficiency?
All right, Cyril, thanks for asking the question. Pearl Engineering does not have a chart or guideline for that, but to evaluate the efficiency of gas burners, really requires a good analysis of the flue gas constituents leaving it, and you can perform a efficiency evaluation and performance test on the boiler. That's going to help key you into how efficient your burners are and how efficient your boiler is. That's something that we can offer to look at and help with, but we do not have a chart or a guideline necessarily for that. But thank you for asking.
Oh, looks like we have another comment from Steve Abbott. He looks like he knows where his next tube leak's going to be. It's going to be on the handhole cap bolted on the square header.
That is pretty common. I don't know why that design is as popular as it was, but square header handhole caps, I have seen those leak a lot. So thanks.
All right, it doesn't look like we have any other questions. Ciro, please feel free to chime in again. Let's carry on with the second part of the PowerPoint.
All right, it's important to stay on top of your performance of your boiler. Combustion tuning can mean different things to different people. It'll help improve your emissions and improve your efficiency. If you reduce your excess air, if you reduce your excess O2 by 0.2%, it's not that much if you have an automated system that trims on O2. And yeah, $12,000 per year on a 1,000 kpph boiler isn't a whole lot of money, but over time it can add up. And if gas prices go up, your savings will also go up. The number doesn't look as good as it used to just because of the price of gas right now. Airflow testing. It's important that airflow testing is done every 5 years or so to ensure that your combustion air matches what your DCS or your PLC reads. If you have, whether you have pitot tubes or airfoils, your measurement's just based on a DP. If there's any sort of pluggage or if there's damage or leaking on the pitot tubes or airfoils, the conversion from the differential on that device to the airflow that you're controlling your air to fuel ratio off of is thrown off. Real-time testing with a handheld calibrated pitot tube can help you to characterize your device so that it is accurate. Your SIP blowers can be optimized. You could be wasting a lot more steam than you need. There are smart SIP blowing systems out there. There are acoustic devices that can be installed on your boiler that can really help dial in your SIP blowers. It depends on how far you'd like to go with that. And unit performance testing, like I said, it can help tell you your efficiency of your unit as a whole, and if there are other improvements that you need. It can also help kind of key you in if you have, especially to your auxiliary systems, make sure that your deaerator and your air heater are performing as efficient as they should be. With combustion tuning, here's a sample of a map. Like say you have, if you would install a temporary grid, and this example is 2 ducts leaving your economizer, or 2 flues leaving your economizer, and you're measuring 4 deep and 6 across each flue. You can see that in most units, you're not going to have a laminar value for O2 or CO or NOx. This example, towards the top center, you have 3.5% O2, excess O2. Down on the bottom right, you're around 2.3. Now, if you're controlling the 3.1%, you could see that you're controlling it. Your control points for your O2 probes are only in one place, or maybe you've got 3 across. But you're really missing, if you have a multiple burner boiler, you can make changes to your vanes on your boiler, on your burners themselves, and you can balance this across. Now, the rule of thumb is you've got carbon monoxide, excess oxygen, and NOx. You can improve 2 of the 3. If you do a grid map and you've got multiple burner boilers, you can get this, if you can make it as even as you can across the board, you can actually improve all 3, because you're not going to have a peak of NOx where you have 3.5% O2. You're not going to have a peak of high CO where you have 2.3% O2. So you can end up balancing it so that at your stack, you're actually reporting better emissions values. Let's talk about some unforeseen consequences. So over time, as the emissions controls have gotten more stringent, hopefully you've been able to have some capital projects at your boiler, at your facility, to help improve and get ahead of the new emissions regulations. If you add overfire airports, you need to go and look at, okay, do we have reducing atmospheric corrosion attacking our water walls? So it's important to get in and perform inspections. If you add in an SNCR, do you have ammonia slip now? That needs to be tested. I've seen ammonia slip on an SNCR go unnoticed due to over-injection of the ammonia because it wasn't tuned properly, and the SIM system was poisoned so that the SIMS equipment could not read values and the unit had to be taken offline. Or you're just injecting extra ammonia that your facility's paying for, but it's not really reducing your emissions. It's similar for if you have an SCR, only there you can get extra corrosion risk, more so on the SCR than with the SNCR. Dry sorbent injection, if you're over injecting, you can plug up your ductwork. You're not improving your emission quality at all, but it can lay out if you're over injecting, and you just have to pay for dry sorbent that is not providing a benefit. Say you change the operating range of your boiler. It used to be a base load unit, and now you're running as low as you can to still maintain heating steam, but your electrical generation output is low. Or you converted to natural gas, so from coal or from biomass. Anything like that can change the range at which you're operating your boiler. Typically, it may not be where it was designed. you can have vibration and resonance in your backpass and in your breaching that could cause internal stiffeners to fail. It can cause a vibration that just makes excessive noise in your building. That can actually be found by hammer testing and acoustic monitoring inside during an outage, and you can help find what components internal are causing that vibration and resonance. Anytime you modify ties and attachments, like say for superheat pendants, it can sound like a good idea, but there's no really good way to tie superheat pendants. Every manufacturer has a different method, but I have seen places make changes and alterations to try to reduce tube leaks and have ended up having multiple forced outages and gone back to the original design. Installing tube shields, I don't know how many times I've been asked if installing tube shields can hurt your heat transfer. It can't. That is a misconception. Install as many tube shields as you possibly can. Here's a photo of some custom baffles that I had installed in the backpass at a boiler within the generating bank, and you can see we shielded every tube across on the bottom of that bank. And again, the transition point between the hanger tubes and the boiler bank tubes that it's supporting, that area was getting hit hard by the soot blower, even though it's about the furthest point that you would think the steam can reach off the blower. So armor up as much as you can. Please install at least 10 gauge tube shields. Typical rule of thumb, tube shield is going to cost you about $100 to install by the time you pay the Boilermaker labor and the material, but it's a pretty cheap investment that can help keep your unit online. We'll take a little bit of time for any more questions.
Mike, I don't see any additional questions right now, but we'll just give it a couple more seconds.
Okay. All right. Yes, thanks everybody for taking time out of your busy schedule today to attend this webinar. Hopefully you got some benefit. We do have upcoming webinars August 5th to discuss Pearl Engineering's 3D scanning capabilities, and we'll do a specific presentation on boiler tube failures, different methods that would cause failures, and ways to prevent them. We also plan on having a webinar about stack inspections and a more in-depth look at boiler optimization and combustion tuning coming up. If anyone has follow-up questions, please let me know. You can call me or email me anytime, even if it's just to discuss an issue that you're having at your plant, or if you'd like to get more in depth into this. I just like talking about boilers. And here at Pearl Engineering, we're responsive, we're ethical, and we'd like to help you in any way that we can.
Yes, thank you everybody for joining. We're going to conclude today's webinar. If you have any questions, we can absolutely reach out to Mike at that email. There will be a live recording available after that Microsoft Teams should send to you. Otherwise, we'll also have it on our YouTube channel, link to our LinkedIn page. Please stay in touch on our LinkedIn. We're very responsive on there. So everybody have a great rest of their day. Thank you very much.